Hi, my name's Mike of 71 Squared and welcome to tutorial 5 on our series on writing a game on the iPhone using OpenGL. So this tutorial hopefully shouldn't be too long and is going to cover a class which is going to allow us to animate our sprites. So we've already got our image class, which is getting us to render or allowing us to render sprites to the screen. We've got our sprite sheet class, which is letting us have a sheet of sprites, and we can then just access them by providing an X and a Y coordinate, and we can render that sprite. So building up from that, what we're going to do with animation is be able to create a series of sprites, if you like, or be able to read in a series of sprites that when you display them one after the other, a little bit like the old flip books, you'll be able to see an animation running. So it's not a complicated class and it's really useful. I don't think any game that I sit and write is going to be very much used without some animation. So we'll jump straight into it and we'll have a look and see what it takes. So, oops, I opened the wrong one there. So inside my tutorials, I've got tutorial 5, which I'll just quickly open up. Okay, now before we quickly start, there was a post that I put on the blog about the main game loop, and I had a post on that, I had a comment on that, which was identifying an issue. And when I had a quick look, it was to do with performance being very slow. When I had a look at the code, I realized that what I'd posted on the blog entry was incorrect, and that this number here was actually on the blog shown as 0.02. And in fact it should be 0.002, which is, how long are we giving the CF run loop to execute, to how long we're giving it to actually process events that are on the queue before it's going to hand back to us. To having that very long figure meant that it's waiting a long time inside this while loop, looking for events to process on the queue before handing control back to our game loop, which meant that it was running very slowly, and also if you had anything like touches happen, then that was causing the game to slow down as well. So in my testing, I found that 0.002 has been a good value to have, and so far hasn't caused me any problems and has meant that I've been able to pick up rapid touches to the screen without it causing the game to slow down. So just a quick update on that before we get started. But what we do want to do is we want to create our animation classes. We want to be able to create this piece of animation which we're going to use a series of sprites through to actually flick them one after the other onto the screen. So what I'm going to do is inside our engine I will create a brand new group, and I'll call this animation just so that it keeps everything together, and I'll then create a new file. The file is of type NSObject subclass, as we're doing with all of the objects that we've been creating to date, and I'm going to simply call this animation. Okay, so inside our animation file, we want the animation.h file. Inside here, what we want to do is we want to be able to set up now the properties for our particular piece of animation. So I've got the properties that are inside the header file, which I'm just going to paste in now so we can have a look and see what we've got. Okay, so we've got an NS mutable array is the first thing, and this is going to hold our frames. Okay, so one frame is one image, and we want to have a series of frames that we can display on the screen at our own speed, allowing us to generate the animation that we're after. So this NS mutable array is going to hold our frames, if you like, and in a moment I'm going to be creating another object called frame, which will hold information about each frame, such as the image, the amount of time it should spend on screen, etc. The next thing I have is something called frame timer, and this is what the animation is going to use to accumulate time. So we want to have a frame appear on screen for a defined period of time before the next frame appears, so we can make the animation faster or slower as we need to. So every time we run or we update our animation, we're going to pass in delta, which, if you remember, is the amount of time that has passed since the last update inside our game loop. And that will be accumulated to frame timer. And once frame timer exceeds the amount of time that the current frame should be on screen, it'll then move to the next frame. So that's what frame timer is going to do. We then have a few booleans. So we have one called running, which is going to identify if the animation is running or not. So if this is yes, the animation will be running. If it says no, the animation will be stopped. We've also got repeat, which as the name would imply, it means that should we repeat the animation when we get to the end, or should we just run through and stop when we get to the end? And we have one called ping pong, which is when we get to the end of the animation, if repeat is on, it would actually just go back to the start, back to frame 0 and start again. Ping pong means that it will get to the end and then it will just play in reverse and just keep going that. So it will play forwards, then play backwards, then play forwards. So it will just ping pong backwards and forwards. We then have direction, which is which direction is it playing in. So is the animation currently going forwards or is the animation going backwards? And we also have current frame as well, which is what is the current frame of the animation that we're running. So there are properties, and what we want to do is set up some property configuration for those for the getters and setters. So I'm just going to pop that in here. So you can see really straightforward. These are things: repeat, ping pong, running, current frame and direction are things that we may want to read or change. So they've been defined as properties, and getters and setters will be set appropriately. We then need to add the methods that are going to be important to our animation. So the methods that we're going to be popping in are add frame with image, which, as the name would imply, this allows us to add a frame or add an image to our animation. It takes an image as input, and that image could be taken from a sprite sheet, which we'll have a look later on. And it also takes a delay. Okay, so this is the amount of time we want this image to appear on the screen. So by giving each image a delay value, you could actually have an animation that runs fairly quickly and then slows down, pauses for a while, and then runs really quickly again, or whatever combination of frame delays that you want. But it means that the animation isn't going to always have to run at a set amount of speed or at a set speed. It means that the actual animation can change its speed throughout the animation as defined per frame. We then have an update method, which is going to be called by our game logic. So for every animation we run an update, and this will basically take the delta, which is the time since the last run, and that will then get accumulated to the frame timer. So this is how we're going to know whether we should switch frames or not. We then have a render at point, which is quite common to some of the other classes we've created. And render at point is going to take a point, and it's at this location that the actual animation will be rendered. We then have some information which is going to be useful, is get current frame image. So we may want to grab the image that is the current image in our animation, so we can do that and return an image from it. We then want to say what's the animation frame count, so how many frames are inside a particular animation. That may be something we want to find out. Get current frame number, we may want to understand what the current frame number is as well. And we have another one here, which is get frame for a particular frame number. So you may want to actually grab a frame from the animation at a particular location and then have a look at the information inside that. So that's another convenience method that I've added in here. But that's it. That's the header file inside animation. So it's not particularly big. It shouldn't be too complicated either. So it means that we can actually go and have a look at the .m file and look at the implementation in there. So I'm just going to save the .h file. So that's done. And then we'll start creating the .m file. So the first thing we want to do is we want to synthesize our getters and setters, or synthesize so it can create our getters and setters, which we've done there. And we then have an init routine. Now, the way that I've designed the animation class, or the animation object, sorry, is so that you can initialize it and then you add frames to it afterwards. Now, I probably will change this later on. I may adapt this so that I could actually maybe initialize it with an array of frames already created, all in the same go. So there may be some other convenience methods that I'll add later on. But for the moment, what you do is you allocate and initialize an animation or an instance of animation using the init method. And what that does is it creates an array of frames. So it allocates and initializes a mutable array, which we're calling frames. We're then setting some default values. So we're saying current frame is 0 because there aren't any. The frame timer is 0. We're setting running, repeat, and ping pong as no. and we're also setting a direction here, which is called K direction forward. So in fact, that's one thing that I've forgotten. What I need to do is back in the .h file, I created a, oops, I opened that by mistake. In the .h file, I created a very simple enumerator, which we can use, which specifies the direction. So just above the import here, I'm going to pop the enumerator that I created, and while I'm here I'll also add the imports that I'm going to need. So I'm going to import my sprite sheet, okay, because I want to be able to grab sprites possibly, and I'm also going to import something called frame.h as well, and frame.h is something we're going to create in a moment. So inside my enumerator I've just got two enums. One is called K direction forward, which is equal to 1, and one which is called K direction backwards, which is equal to -1. Okay, so very straightforward. If I go back to my animation.m file, we can see that inside my init routine I am just setting the direction to forwards. So by default, when the animation is created, the direction is forwards. Okay, so let's carry on. Now the one thing that we need to be able to do inside our animation is we need to be able to add a frame, otherwise the animation is pretty useless, to be honest. So that's what the next method is going to do. So this add frame with image method, it takes an image, which is going to be the texture that is rendered for this particular image, and it takes a delay. So once we've actually called this method, what we do is, first of all, we create a brand new instance of frame, which is an object I'm going to create in a moment. And we allocate that, and that's going to have an init with image and delay. So what we're doing is we're saying that when we actually create a brand new frame and add it to the animation, we create a new instance of this object called frame, and we initialize it with the image that's being passed in and the delay that's been passed in. Once we've allocated that new frame, we then actually add that to the frames array. Okay, so as we said earlier, the frames array is what we're going to use to store all of the frames inside our animation. So what we do is when we've created our instance of frame, we add that frame instance into our frames array. What we then do is we release frame. Okay, so the way that this works is, as with most of the other arrays that we've been using, because when we actually add this frame object into the frames array, it actually increases the retain count. It means that we can then release frame at this point, which will then reduce the frame count by 1. So allocating will basically give frame a retain count of 1. Loading it into the array will give it a retain count of 2, but then releasing it will take it back to a retain count of 1. So that if this object is removed from the array and the retain count is reduced again, it will have a retain count of 0, and it will then be freed from memory. Okay, so once I've added it to the array, I know that the array has got a retain on it, so I can release the retain that was actually added when we allocated it. Okay, so the memory management is handled for us okay. So that's it. That's very, very simple and straightforward, what goes on inside the add frame with image. And the next method we're going to cover is the update method, which is really the guts of animation. This is what does all of the work in terms of actually working out which frame should be rendered. So what I'll do is pop in that method. Okay, so we'll take a run through this now. The method is update, and all we do is we pass in a delta value. And as we say, that delta value is the difference in time between when the last update ran. Okay, so in other words, every time we go through the game loop, we say, what's the difference in time between when we last ran through the game loop, and that we call delta. And that delta is then passed into here, and the way we're working out is in milliseconds, so that we can see how many milliseconds has passed since the last time we ran through the update routine. And then we can actually increment our timer, so we can keep track of how long the current frame has been on screen. So once we do an update, first of all we check to see if the animation is running. If the animation isn't running, then it's a bit of wasted effort really to go through the processing, so we just return. We don't bother doing anything. If the animation is running, then what we do is we update the frame timer with the delta value. So frame timer is tracking how long this frame has been visible. Once we've done that, we then actually have a look and see whether that exceeds the amount of time this particular frame should be on screen. So we're saying if the frame timer exceeds the amount of time, which is the frame delay, for this particular frame to be on screen, And what we're doing is we're actually referencing this particular, we're referencing the frame delay value for the frame we're currently on. So what we can do is we can use this command structure here, which says from the frames array, go and grab the object which is at index and then current frame. So current frame is the current frame. So if that's maybe frame 3, then we can go and grab the object at index location 3 from the frames array, and from that we get the frame delay. Okay, so that's what I'm doing in here. So if the frame timer is greater than that delay, so in other words, this frame has been on screen longer than we've defined, so we now should be moving to the next one, that's what we do. We increment the current frame by whatever the direction is. So remember, by default, we set the direction to be 1, which is forward. So we say current frame basically plus equals 1. We then reset the frame timer, ready to be able to accumulate that again. And then we do some checks. So we say if the current frame is greater than the number of frames in our array minus 1, because obviously the frame array is 0 indexed. So in other words, if we've gone past the end of our array of frames, okay, and the current frame isn't less than 0, because we've got to do this for both directions. So if we were going forward, if we'd reached the end, we want to know about it. If we're going backwards and we've reached the beginning, which is the less than 0, we need to know about it as well. In either of those situations, okay, we need to decide what to do next. So if we've reached the end or we've reached the beginning, what do we do? And that's what these next little checks do. So if we're ping-ponging, so in other words, if ping-pong has been defined, then what we're going to do is we're going to change direction. So we're going to say direction equals minus direction. Okay, so if we're going forwards, which means that we've got 1 as the direction value, then doing minus direction will be minus 1. So you can see that next time we run through here, we can say current frame plus equals minus 1, and it will actually mean the frame index is going backwards. If it's minus 1 and we say direction equals minus direction, sorry, if we say direction equals minus direction, then because we're saying minus 1, sorry, yes, because we're saying the direction is minus 1 already, minusing the direction, 2 minuses is a plus, basically, if you remember your maths. So we're then making that back to 1 again. Once we've done that and we've identified what the direction is we need to go in, so in other words, we've switched the direction, we then add that current frame direction. So in other words, if we've gone over our number of frames, we want to start going backwards, so we go back 1 frame. If we've got to the beginning of our frames, then we want to go forwards, so we end up going forwards 1 frame. So that's our ping-ponging. That is really it. That's how we manage to bounce from one end of the frames list to the other. If we have repeat and it's not ping pong, so if we want to repeat this and we're not going backwards and forwards, then all we do is we reset the current frame back to the beginning and then it carries on running again. If it's not repeat and it's not ping pong, okay, so in other words, we're not going to bounce backwards and forwards and we're not going to repeat it, then we stop running. We run through the animation once, and if neither repeat or ping pong are set, we stop. So we say running equals no, and we reset the current frame back to 0. And that's it. That's all of the logic that we need to actually be able to manage which frame should be displayed on screen and in which direction we're actually running from. So that then leaves us with a few other simple methods which we're going to run through now. So the first one is going to be our render at point method. Okay, so this is what's going to actually be used to draw this particular frame to the screen. Okay, now at the moment we can see that when we render, what we do is we initialize a frame object, and we initialize that to be whatever the current frame is. So we go back to that frames array and we grab the index or the object which is at the index current frame, which is the frame we're currently displaying. Once we've done that, we then access that frame image and we access the frame image, okay, which is the texture that's going to be rendered. And because that is an instance of the image class, we can call the render at point method, passing it the point that was passed into our render at point call here. And we can then also specify by default that center of image is used yes. Now this can be enhanced actually, because at the moment when I render animation, I'm always rendering it in the center of the animation. I haven't got the center of image value being taken, which means we could change that. So that's something we can add later on. If you want to add that, very straightforward to do. But that's it. That's what we use to actually render an image for this particular animation. So then we've got a few of those convenience methods. So I'm just going to pop those in now. Okay, and we'll just add those here. Okay, so we had one which is called get current frame image, which really simple. We go to our frames array again, and we say for the current frame, just pass back the frame image. And so we're passing back an instance of image, or at least a reference to that image. Okay, we don't pass back a copy, we pass back a reference to the frame image, and then we can do with it what we wish. We then have get animation count, which is passing back how many frames there are. So we just do a count inside our frames array. And we then have a look at get current frame number, which is very straightforward. We just return the current frame, which is obviously tracking the current frame number. We then do the final one here, which is we say get frame for a particular frame number, and we do a quick check. So if the frame number which is passed in is outside of the count of frames we have in our frames array, then what we want to do is return nothing, nil, and just put a warning out to the log file, just to let the person who's developing the game know that we're actually trying to access a frame that's out of the bounds of the current frames in our animation. Okay, if it isn't out of range, then what we do is we actually return the frame. We actually return whatever the frame is at that particular frame number. Okay, so we're taking the frame objects which can be found at index frame number, and we return that. And that's all the methods. The last one that we have to think about is just the deallocation method, which I'll drop in here now. Okay, and there it goes. Okay, now, and what we're doing in here is that we're just releasing the frames array, because as you remember back up inside the initialization routine, we're allocating it. So because we're using alloc, it means it's getting a retain count of 1. That being the case, that means we need to release that particular frame when we're done. And that's it. That's the core animation class done. It's pretty straightforward, pretty simple. It could be enhanced in many ways, but for the moment, that's pretty much all I need. So I'll save that. And what we'll now do is we'll create our frame object, which we reference. So if we select add again in a new file, and it's still going to be an NSObject subclass, and this is going to be called frame. Okay, now this is really, as we said before, just going to hold information about the particular frames that we have. This could, to be honest, have been a structure. So you could have created a struct inside the animation file and just had an array of structs to make things quite simple and to save you using things like NS mutable array. NS mutable array and any of the NS arrays do have an overhead because there's lots more checking that is being done than a straight C array. But to be honest, in the stuff that I'm doing, I'm not really noticing an overhead which is causing me a problem or which is causing the game to run slowly. So for the moment, I'm actually creating a separate object called frame, which is used when we're storing each of the frame properties. So in here, what I want to do is I'm going to import the image objects that I've got, and I'm going to assign a couple of very simple properties. Okay, so the first property is called image, and that's what's going to hold the frame image reference, and the second one is called frame delay, and as we know, that's going to hold the delay, how long that particular frame should appear on screen. I'll then pop in the two property entries like so, and they are obviously, one of them is assigning the frame delay and the other one is retaining a copy of the frame image. And lastly, we have an init routine, which is just there, which takes the image and it takes the delay. So I can save that because that's all I need inside my frame.h, and then we can do the frame.m, which is really, really straightforward. So in fact, what I'm going to do is I'm going to place everything in here in one hit because it's only small. So first of all, as normal, I synthesize to get my getters and setters, and I then have my init with image, and all that's doing is it's taking the reference to an image file and it's taking the delay amount, And all I'm doing is setting those. There's my frame image becoming equal to image, and there's my frame delay becoming equal to delay. And that's it. There is really no functionality inside of frame. It is just a storage object, if you like, which is why a structure could be used. But just because of the 00 nature of the way that I like to work, I've just left it there. If I noticed it being a problem with very large animations and maybe taking up too much memory or whatever may pop up later, then we could adjust it. But for the moment, this is working fine and it's okay for my needs. But that's basically it. So if I save that and I do a build, okay, let's make sure everything is saved. Just to make sure I've not introduced any errors. And so the build has succeeded, okay, so there's nothing obviously wrong with it. So now we can actually test it out. So I've got my sprite sheet 16 here, which we've used in some of our other examples. And as you can see, these are animated sprites. So each sprite is in a slightly different position to give it some animation. So what we'll do is we'll look at going in and actually animating one of these now and showing how we actually use the animation class. So inside our EAGL view.m file, I'm going to go to the top where, oops, here we go, where we're initializing our game. And in fact, what I'll do first is if we go to the EAGL view.h file, I need to add an import at the top, which is going to be to our animation object. And then if I just scroll down to the bottom here, I'm going to add animation and I'm going to call it anim just for the sake of it. So we'll save that and we'll switch back to the .m file, and in here I'm going to say anim equals, and if you remember we define animation alloc and init. Okay, so that's how you would initialize the animation, okay, and by doing that, that's actually just setting up the default values inside animation. Once I've done that, I need to add my frames. So because my sprite sheet is quite neatly set up in rows here, I can use a for loop and just loop round and pick them up. So I'm going to pick this first, in fact, no, I'm going to pick this row down here, which is 0, 1, 2, 3, because it's a zero indexed array that we'll use. So 0, 1, 2, 3. So it's row 3. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 actual sprites used for that animation. So back inside EAGL view, oops, let me just check, what was that? 1, 2, 3, okay, that was 3. So back here I can do my for loop. So I'll say for int index equals, and we'll go from 0. As long as index is less than 17, that was how many there were, and we'll actually increment index like so. And what we'll do is we'll say anim add frame with image. Now the image we're actually going to take from the sprite sheet, and you'll see that from earlier up here, that's where we're defining our sprite sheet. For sprite sheet 16, it's called SS. So what I'm able to do in here is do square brackets SS get sprite at. Now the row was 3. Sorry, the x index is going to be index, okay, which is part of our for loop, and the row was row 3, and then I can close that off. And what I'm going to do is I'm going to say I want 40 milliseconds. That's how long I want this to be on screen for, and then I close and semicolon and finish the for loop. And that's it. So what this is going to do is loop round 17 times, and each time round it's going to grab a different sprite from the sprite sheet and add it to our animation. That's pretty much it. So I'll build that just to make sure everything is looking okay, which it is. So the next thing we need to do is we need to make sure that our animation is updated each game loop. So inside our update scene, I'm just going to add the anim update, and delta is what we pass in. So that will update the animation based on the delta. And inside our render scene, I'm going to just pop here at the bottom. I'm going to say anim render at CG point make. And what I'll do is I'll do 160 in and 200 up, like so. Okay, so build that. No errors have been reported, so I'm going to run it and we'll see what we have come up. Okay, and there we have our animation, and you'll see it's actually not doing very much. Now the reason is that I forgot to tell it to start. Very silly of me. So I'll go back And what we'll do is back inside the initialization code up here. Okay, once we've actually set up the frames in our animation, I'm going to say animation set running is yes, so we want it to set running. And I'm also going to do animation set repeat equal to yes as well, because I want it to repeat. Okay, so I'll build that just to check. Okay, it's fine, and then I'm going to hit run. Okay, and it's actually still not looping through anything. So let me have a look here. What have I missed? Oh, I've got repeat on here, not running. Set running like that. Right, let's run that again. And there we go. You can see that we've got our animated top. So it's just that little sort of spinning top flipping over and over and over. Okay. So if I stop that, if I actually increase this time here, if I double it, okay, and run again, you'll see that the animation actually runs slower. So there we go. The animation is actually running a lot slower now. Okay, so that's how you can control the speed. If I actually went up again and I said 120, it would run even slower still. There we go. So that's how you define the speed. And again, at the moment, I am actually defining a uniform speed. I'm saying that for every frame, the speed is going to be 120. You could change that per frame. Okay, so you could actually have a frame. I could say the delay is going to be whatever the index is plus 10. Okay, if I run that, that means that it should be fast and get slower. Hard to say really, because that's actually quite quick anyway. So let's add something on here. Let's make it 30 on there instead. Yeah, so that's a little bit better. You can see that it's very quick to start off with, and it sort of then slows down towards the end. So you don't have to have every frame with the same delay. So I'm going to pop this now back to our, I'm going to give it 80 because that was a reasonable speed. And then we'll try something else. So if we have repeat equals no in this now and run it, we should see that it'll go through once and then stop. Okay, so we're saying we don't want it to repeat, we just want it to run once and then finish. We could also have ping pong on. So if I say animation set ping pong to yes, this should mean that it will actually go forwards and backwards and forwards and backwards and keep doing that. So there's the forwards, and there's the backwards, and then there's the forwards again, and there's the backwards. So that's it. That's all the stuff we've got on our animation really. You could do other things in terms of referencing the image inside here. So you may want to rotate the image if you wanted to. So what I could say here is that for every single image, I want to change the way it is for that particular sprite or that particular frame. So I could say anim. And let's have a look. Anim. Let me think. I've lost track of what I was going to do now. Anyway, I'll think about that. Completely lost the train of thought there, which is terribly unprofessional. It's what happens to trying to do things on the fly. But I think that's shown you what you can do with the animation class. It's pretty straightforward, very, very simple. Shouldn't have any problems with it. And it is just a really useful, versatile thing to use. It really can be quite useful. One thing I will do just before we finish, let's just animate a different sprite. So what I'm going to do is I'm going to pick this guy down here. He's quite a cool sprite. That's one that we've seen before in one of my videos. So he's 0, 1, 2, 3, 4, 5, 6, 7. In fact, no, let's do the explosion. That's a common one. 0, 1, 2. So that's 2 and 1, 2, 3, 4, 5, 6. So that's 2 down and 6. So we want it to go up to 6, and it's going to be 2 down. So let's run that and look at our little explosion. There we go. So that's obviously ping-ponging backwards and forwards at the moment because we've got ping pong on. So I'll get rid of ping pong. Okay, and I'll just say yes to repeat. So we should just keep seeing the explosion going over and over again. There we go. So hopefully you'll find that useful. The animation is certainly something that is going to be, I think, very used in a game. Otherwise things can be pretty boring. And that wraps up the animation side of things. I'm currently going to be working on the tile map class, which is that's going to be quite a big tutorial because the tile map stuff is quite involved. Mainly, not so much from the rendering point of view. That's fairly straightforward. I'm using the same rendering technique that I use for the bitmap fonts, which is the vertex arrays, just to really get the performance that I'm after. But really because I'm using the output from a tool, from this TileD map tool, it generates an XML file, and you have to process that XML file to understand what's going on with each of the tiles, so you can then draw your tile map. Obviously I'll talk about it more once we actually do the tutorial, but the loading itself, it's an XML file, and I found some performance issues with something, the NSXML parser, which is the XML parser that comes on the iPhone. NSXML document, which is the code for being able to open up an XML document, be able to traverse it, look at the nodes, look at the attributes and all those sorts of things, that actually isn't included in the iPhone OS inside the Cocoa API. So what I've done is I've actually implemented something called Touch XML, which is based on the libxml2 open source XML library written in C. So I've implemented that and used that to actually read in the XML, so it's a lot faster. So the tile map class is going to be quite a long class because we cover off implementing the Touch XML API, we cover off parsing the XML file so that we actually can load the map into memory, and then we cover off the rendering of it. It's working really well. It's very, very fast. I've got it hooked up to the accelerometer, so as you move the character around, you fly around the map just for testing, and it's coming up at 60 frames a second and really nice. So really pleased with it. It's come out nicely. So well, that's the next tutorial I'm going to be working on. And as you would have seen on the blog, some of the other things I'm having a go at are things like the 2D particle system. I think that's going to be quite an interesting one to get working as well. So that's a sideline that I'm working on. So again, hope you've enjoyed it. Please post any comments or questions that you have. As always, the project for this tutorial is posted along with the tutorial video, so you can download all this code and have a look and have a play. And I hope you find it useful. Thanks very much.